You're recording already.
Oh my gosh. Let's make the homework. In 5, 4, 3. It's pre-calculus time. And I have to pick up some homework, so I'm going to leave the screen now. Thank you. Start your host, Pete Wade. And the live studio audience.
Do a rap. Sign that you can
Let's do patterns.
Always have to laugh. Yeah.
I'm going to great applause. Okay. All right, let's see what we have here. Find d and y over dx in. Now, what in the world is d and y over dx in? Which one? You know what? Is that the nth derivative? Yes. What that is? Like the master formula for any derivative at any time? Okay? This is kind of like an explicit formula for derivatives, is what this is. Okay? Instantaneous formula. All right, let's see if we can do that. Well, let's start with the first row right here. Let's figure out the first row. And I'll tell you what you ought to do. If you give yourself 3 or 4 derivatives, you'll see a pattern, and then you can write the pattern in one big form, explicit form. Okay? So let's take a couple of derivatives, see what happens. All right. dy dx is our first one. And who knows what rule we have to use for this derivative? That is product rule. Very nice. Stephanie, right? Okay. All right. So this one stays the same. Times d high, which is 2, plus high times d ho. Exponential derivative. Isn't that stays the same times
Natural log of the base.
natural log of the base? What's the natural log of e? 1 times the chain rule.
1.
Oh, just stays the same, doesn't it?
I don't know.
It's e to the x times 1 times 1. Right? So for e to the x, you can actually skip the other 2 steps always, because this is going to be 1. All right, very nice. Okay, well, let's see. What do we do next with this awful looking equation here?
Take out, but that's the same.
Okay, why don't we try to factor out some kind of common factor, right? That'd be a great idea. Make it look nice for yourself, because you have to do another derivative of this. What is the only common factor between these two?
E to the x.
E to the x. You know, it's tempting to take a 2 because 2's here, 2's there, but there's not a 2 over that one. If you can't take 2 out of everybody, you can't take it out, right? So only take out the e to the x. Okay, so let's see. First, this is going to be what's left over here. 2. Okay, take out e to the x. What's left over down here? 2x plus 1. All right. And now it's time to play one of our favorite games, Mr. Wade's Farm. And on Mr. Wade's farm, he has 2 pigs, plus 2 crocodiles, plus 1 more pig. Who's going to say I have 2 pigs and 1 pig? Put them together, right? I have 2, what do I have? Crocodiles? Yeah, crocodiles. Plus 3 pigs. Okay, put it together, consolidate, of course. All right, and there is your first derivative. Okay, let's take the second derivative. Let's go to the next row there. How do we take the...
That's cute.
That's the classic so cute sneeze.
Yes. Seriously, every time.
You're going to become famous for
Okay. After that brief interruption there by Steve Q, we have to take another derivative. So how do you take another derivative of this?
Product rule.
It's a product rule again. Sure. All right. We're going to see the pattern of the product rule today. So, ho d high, so that would be 2x plus 3 times, what is d high?
E to the x.
E to the x. Plus high times, what's d ho? 2. All right. So now we know when we have e to the x, you can just take the derivative and make it e to the x, right? It's just what it is. Okay. Now remember in the future though, if you have like 3 to the x, you'd have to do 3 to the x times natural log of 3. Don't forget that. Okay? But for e's, you can just bypass. All right. So I'm sure there's some kind of common factor I can take out here somewhere. All right. So take out e to the x, and then you're left over with 2x plus 3 plus 2, but we can put those like terms together,
So you're
can't
sending
we?
too
Right?
much.
Old Mr. Wade had a farm, E-I-E-I-O. And on that farm, he had two
Pigs.
pigs again, and 3 monkeys and 2 monkeys. But he's just gonna say that, just say I have 5 monkeys.
Crazy farm.
I'm pretty sure that's like illegal.
Might as well put them together. Oh, that's
Plus
fine. I got my cages.
Plus.
I mean, after all that,
Very
put plus 3. Okay, plus 5. All
And
right,
the other two.
that's the next derivative. Now, let's do the third derivative, but
Just
let's
have
not
two.
do the product rule, let's see the pattern. I spy a pattern.
Yeah.
Somebody else spy a pattern here?
Plus
seven.
two.
You even go back to the original function, plus 1, plus 3, plus 5, so it's going up by 2 every time. That's part of the, which formula is that, by the way?
Explicit.
Now, the other one.
Recursive.
Yes,
Recursive.
each previous term was plus 2 to the next term. How do you get to the next term? But I can't just do that for the explicit. How do I get to the general, okay, but for pattern? All right, so let's go ahead and justify this to the right. And dx, d cubed y over dx cubed would be e to the x times, I'll bet it's 2x plus 7. All right, and I bet the fourth derivative, let's do one more. Because you can always see the pattern better in step 4 than you can in step 1. We're going to look down here, right? And the fourth derivative is going to be e to the x times 2x plus 9. Okay? So one of the patterns is to go up by 2, up by 2, up by 2. That's your recursive pattern. But the explicit, right? Let's go over here to the next column. So see where it says derivative. In the derivative column, all right? What derivative was this one right here? This one was the,
Product.
okay, that was just the first derivative using the product rule, right? Okay, so that's derivative number 1 right there. This one was the
Second.
second, and then
Third.
third and
Fourth.
fourth. Now, when you get to this one, we are on the what derivative first? That is the nth. Okay, so that's the very bottom box. We're going to say that last row right there to do the formula. Okay, so that's the nth derivative. You know what this is like when you look at this column? We did this with sequences. Remember the 2 little columns we did in the boxes?
Yeah.
This is the what column? Which column do we have? 1, 2, 3, 4, 5, 6, 7. Wasn't that the, but back when the sequence was there? Wasn't that the in column? And we have like an in column and an a sub in? That's your in column right there. That's counting each term of the sequence is what that's doing. Okay? So your in column is always going to be 1, 2, 3, 4, 5, 6, 7. Okay, now the other column. The other column is the magic changing number. And there's only one changing number here in this problem. Okay? In the first derivative, it was that one right there. E to the x stays the same throughout. We kind of got that part. 2 to the x plus, that stays the same throughout. We got that part. But how do we get this? Okay. So this was a plus 3. What was the magic number of this one right here?
Plus
5. And this one was 7 and 9. So I know it's going plus 2, plus 2, plus 2, recursive, but explicit. Can you wave a magic wand and change 2 into 5? Or 1 into 3, or 3 into 7, or 4 into 9?
No.
Okay, oh sure we can. Yes you can, we've done it before. We did the same sequence before on notes. Okay, all right. To get from, and remember, look down lower because it's easier to see down here than it is up here. To get from 4 magically into 9, could we double it and add 1? Does that work?
Good.
Let's make sure it works not just there, but everywhere, right? Double 3 and add 1. Does it work? It does. Double this and add 1.
Yes.
Hot dog.
Hot dog.
Yes, indeed. Once it starts working, you're like, I got it. You can't prove me wrong because I got it. All right? So, the nth term would be, how do you double the nth term and add 1? Plus 2n plus 1. There's your pattern. And that's perfect timing to show you, after that commercial break, that the final answer is, and we'll put it right here, except I'll put it up here, because I have no room. The nth derivative is going to be, what do we know it starts with for sure? What's constant? E to the x is constant throughout, so e to the x times 2x plus, and that number is 2n plus 1 every single time. Just like the easy sequences we did, right? It's a little harder with derivatives, but it's the same kind of thing. Okay, what makes the sequence? How do I get 3, 5, 7, 9? And you find 2n plus 1 and it works. Okay? And so, there you go.
All right.